Hi, everyone. Thanks for sticking with us. We are going to start from the top for the benefit of those who can't see the webinar today, as we will have it recorded and uploaded to our website. Hello, welcome to our webinar today on forests, floods, and climate change along the Wolastoq. We want to use this webinar as a general discussion for the climate science that the research team has completed so far. We have had a couple other webinars, and you can go visit those and watch those recordings. We'll drop a link to the website in the chat here. But we want to use this webinar as more of a general discussion to talk about the big pictures a little bit more. So Interprefy should be good to go. Again, the code is UNBAPR08. And again, we would like to acknowledge that the University of New Brunswick is on the unceded and unsurrendered lands of the Wolastoq people. This territory is covered by the Treaties of Peace and Friendship, which the Wolastoq first signed with the British Crown in 1725. The treaties did not deal with the surrender of lands and resources, but in fact recognized Wolastoq title and established the rules for what was to be an ongoing relationship between nations. The main focus in today's webinar and the overall study is the Wolastoq. The Wolastoq has been the lifeline of the Mi'kmaq, Wolastoq, Passamaquoddy, Penobscot, and Abenaki peoples for time immemorial. And we hope that this presentation can help you learn more about the science of the Wolastoq. While we also understand that there's much more cultural and spiritual learning for us to do to better understand the Wolastoq. So I believe this is where we left off originally, but my name is Tim Turriff. I did my undergrad at Lakehead University in Ontario in outdoor recreation, parks, and tourism. I am now a current Master of Environmental Management student at UNB with my two other co-hosts. And next year, I'm going to Bangor University in Wales, United Kingdom for a Master of Science in Conservation and Land Management. And I'll pass it off to Max.
Hello, my name is Max Lippa. In prior webinars, you may have seen my name is Massimiliano. I'm also an MEM, Master of Environmental Management student here at the University of New Brunswick. I'm originally from Toronto, Ontario, and did my undergrad in Biodiversity and Conservation Bio at the University of Toronto. Next year, I'll be attending the University of Padua for a Master of Science degree in Forest Science.
All right. Hi, everyone. My name is Linus. Like Tim and Max, we're all in the same program at the University of New Brunswick, the Master of Environmental Management. I'm originally from Chicago, but I also did my undergrad at the University of Toronto in environmental science with a minor in environmental biology. And I will also be joining Max next year at the University of Padua, pursuing a Master of Science in Forest Science. I'm going to take over from this point, and we're going to talk a little bit about the research being done in the Upper Wolastoq Basin, pretty much touching on the same things that we just saw in that video, but we can go in a little bit more depth. But first, I want to introduce the three researchers. I believe two are already on the call. I'm not sure if Dr. Shalaby is going to join us today, but they are here to help us answer questions. Starting with Dr. Charles Bork. He is the research lead on this project, a professor at the University of New Brunswick. His research centers on the intersection of forestry and hydrology. With us today is also Dr. Zhenyu Ji. He is currently working at the University of Maryland. And he is his focus is in hydrology and meteorology, and he helped adapt SWOT to the Upper Wolastoq Basin and is developing a decision support system that integrates SWOT into GIS systems to help our land and watershed managers. And last, we'll see if Dr. Ahmed Shalaby can join us today, but he is also associated with the University of New Brunswick right now, and he worked mainly on the climate modeling aspect of this research. Oh, I gotta take control of the presentation. Okay, so let's start with what the research in the Upper Basin consists of. and how it can help us prepare for the changing climate in our region. Before I get started, if anyone would like the highly technical report of the research thus far, we do have that available, and we can definitely send that your way. Just send us an email after the webinar, or fill out the feedback form and include your email, and we'll send that more detailed version your way. So the research was prompted primarily by the 2008 flood, as we've been seeing an increase in significant flood events as the climate continues to warm. So the 2008 flood, for those who aren't from around New Brunswick, I believe most of us are, was a significant flood event. Many areas from Fredericton down south through the lower Wolastoq Basin saw quite a bit of flooding for several days, and there was lots of damage. And we've been seeing more and more flooding throughout recent history. There was a long gap between the first two significant floods in recent memory, so between 1973 and 2008, but now we're seeing more and more severe flooding. So the research team at the University of New Brunswick is conducting a hydrological study in the upper basin to determine how much of this change is caused by the changing climate, and if our land management practices have had any impact, and what we can do to reduce the negative impacts and adapt to the unavoidable ones. So we're really focusing on what specifically we're doing in our land management practices that might be contributing to this flooding, and how we can mitigate that, and then how we can adapt to the changing climate, because it's really difficult at an individual level to be addressing global climate change. The research isn't yet complete, but there are some basin-wide trends that have been uncovered during the process. So on the previous slide shows the study area. This is the upper Wolastoq Basin. You can see it's been divided into 4 sub-watersheds. So that's what I mean when I say sub-watersheds. They're just 4 smaller sections of the upper basin used to correlate data and make it easier to manage. So all 4 sub-watersheds have seen increasing discharge at their outlets from 2001 to 2018. With high rates of discharge, the likelihood of flooding is greatly elevated. This is especially pertinent during the spring freshet or the snowmelt season, as this season has seen the greatest increase in flow rates as wetter winters and warmer springs lead to increased snowpack and then more rapid snowmelt. Currently, we're operating under a snow-dominated system, but with the warming climate, we will most likely see a shift to rain-dominated winters in the next few decades as warm, moist air gets pushed up from the south. This will drastically change the flow dynamics of the river basin as snowmelt becomes. Snowmelt dynamics will shift, so we'll start seeing earlier snowmelt, and then eventually snowmelt may become irrelevant as we shift entirely to rain-dominated. Now, climate change isn't the only factor affecting flow dynamics in the Wolastoq Basin. The continued clear-cutting of forested areas and conversion to agricultural or urban developments leads to a lower resistance to flow in both surface waters and groundwaters. This means that more water is entering the Wolastoq at a faster rate, which increases flow rates, increases water levels, and of course, increases the risk of flooding. So let's focus on the climate side of things first. The changing climate plays an important role in the flow dynamics of the river. Again, with warmer temperatures, air masses expand and have a greater capacity to hold water vapor, which leads to more frequent and more intense precipitation events. We've already started to see these the elevated rate of these extreme events as storms and heat waves sweep across Canada with greater frequency. Just think of BC. Recently, they had all of those fires and then tons of landslides, lots of flooding. And then locally, we had more blizzards in the past winter than we've seen in quite some time. Again, as mentioned, we do expect to eventually shift from snow-dominated winters to a rain-dominated system as the climate continues to warm, and that is going to change the way that the river flows. Climate change is incredibly difficult to manage at an individual level. Our individual efforts do make a difference, but for the most part, we're going to be relying on predictions from RegCM4, which is the regional climate model that Dr. Shalaby adapted to Maritime Canada. And we'll be using that to predict effects and direct management efforts. Curbing climate change requires huge coordinated efforts between nations, as we're seeing through the COP summits and nationally determined contributions. So RegCM4 is really our best way to adapt, get information on how the climate is going to change based on predictions from IPCC and other climate models. But it's a high-resolution predictive model, and it considers 30 climatic variables and puts them at a 5-kilometer resolution. Right now, it's calibrated for Maritime Canada, but it can be used in other areas. And we'll talk more about RegCM4 in just a few moments. Now we've talked about climate change, we should talk about the flip side of the coin, which is land management and its impact on the upper basin. As I just mentioned, land use change is something that we can manage directly. Again, we're mainly talking about the loss of forest cover. In all 4 subwatersheds in this study, an increase in % loss of forest cover correlates with an increase in discharge at the watershed outlet. This pattern does vary based on watershed topography and presence of water bodies such as lakes and small streams, as well as overall water transmission. So things like soil characteristics, surface type, all play a role in the correlation degree of correlation, excuse me, of % forest lost and discharge at a watershed outlet. Furthermore, the intensity of this impact is changing, so we're seeing the same increase in discharge rates from smaller and smaller reductions in forest cover. It takes less clearing to see the same increase in discharge rates as it did, as we see with larger clearings just a few years ago. In particular, spring freshet flows are affected by this change, as snowmelt occurs more rapidly in areas without forest cover, and sparse vegetation in clear-cut or developed areas, which have a total lack of vegetation, lead to increased runoff both in in quantity and in speed into tributaries. So there tends to be more snowmelt, and it tends to enter the water much quicker than when the forest is there. This double impact of land use change and the warming climate puts us at a higher risk of greater flows, and then the inclusion of runoff, agricultural runoff, urban runoff in these snowmelt and these runoff flows lead to reduced water quality. And I want to touch briefly on the hydrology before I pass it off to Max for a little bit for a discussion on sort of the impacts and the key takeaways from the research. So hydrology and flow modeling components of this study were carried out mainly through 2 hydrological models, SWAT, which stands for Soil and Water Analysis Tool, and WETSPA, which stands for Water and Energy Transfer between Soil, Plants, and Atmosphere. These 2 models were calibrated to the upper Wolastoq by Dr. Charles Bork and Dr. Junyu Ji, and used to predict flows and impacts throughout the basin. Both models take soil type, topography, and land use into account, but their outputs are slightly different. So WETSPA is primarily used to predict discharge rate and flow dynamics within the basin. SWAT, on the other hand, is used to predict water quality and resulting changes in soil quality. And we can use those to extrapolate other results, such as potential changes in crop yields and locations of poor quality flows. Dr. Junyu Ji is working to incorporate SWAT into a decision support system for land managers, which should help choose best management practices that mitigate the effects of runoff and decrease quality of upstream flows. And with that, I'm going to go ahead and hand it off to Max.
Perfect. Thank you so much. So I'm just going to go over some tools for mitigation and adaptation and give a bit of an overview as to some of the key takeaways for this research. So when it comes to the climate crisis that we're currently facing, the simplest form of mitigation is to reduce greenhouse gas emissions. Now, greenhouse gases like carbon dioxide, nitrous oxide, methane, CH4, or as some people know it as, and CFCs from industries like electricity production, transportation, heating homes, are creating conditions on our planet where there are impacts associated with the warming conditions. And that was what Linus was going over a little bit. So we need to understand the adaptation that's needed on our end by humans in order to adapt. Climate change is not something that we are going to be able to avoid. We're going to have to adapt to it. So I'm going to look at some of the possibilities when it comes to adaptation. So I'm going to look at the Regional Climate Model 4, as Linus was going over, incorporating structural resilience into building codes, improving regional planning, which Tim is going to go into a little bit, encouraging climate-friendly agricultural practices, and protecting and conserving natural spaces as strategies for adaptation. So in terms of mitigation, as I said earlier, the simplest form of mitigation is to simply reduce our greenhouse gas emissions. Some strategies to achieve this include using less energy. So that includes driving, moving away from driving everywhere and focusing on shared transportation strategies, such as in the summer, using maybe cycling instead of driving to places, turning off light switches, switching incandescent light bulbs to LED lights, upgrading appliances to more energy efficient ones when financially possible. And that also means possibly switching over to climate-friendly energy sources and away from fossil fuels. So relying on rooftop solar energy and moving off the grid is an example. For example, Energy MB has a total home energy savings program that provides rebates for switching over to solar. Eating less meat. Now, this is something I know there's some controversy in this, but generally eating less meat is an acceptable way of reducing greenhouse gas emissions. While livestock rearing only produces around 10% of greenhouse gases in Canada annually, it's the gases that is produced by livestock rearing which are particularly important to note. The main gases from livestock is obviously carbon dioxide, but also methane and nitrous oxide. Methane traps about 20 times more heat than carbon dioxide does, and nitrous oxide traps about 300 times more heat than CO2 does, respectively. So they're particularly bad when it comes to trapping heat and contributing to the impending climate crisis. Reducing food waste. The World Wildlife Fund estimates that a third of global food produced ends up getting wasted. So all that food, there are still emissions that are released to produce that food, and a third of it globally is being wasted. When food goes to landfills, it rots, and methane is also produced. And as I said earlier, methane traps about 20 times more heat than CO2. And then lastly, we should rethink shopping and travel habits. Here in New Brunswick, we have some beautiful local shops and farmers markets. We should utilize those more and reduce any sort of transportation needed to go further distances to specific stores that we may be thinking about, and shopping local, which allows you to alter transportation habits, use less cars, possibly move to car sharing or use the public transport where that's possible. So now we're going to go into the Regional Climate Model 4 for our adaptation. So while the climate model itself is quite technical, which I won't go into too much, we have prior webinars and a technical report if you're interested. We should be concerned with the outputs of this model, as these outputs may be of interest to predict possible future events using various climate variables. So the model that was being calibrated by researchers at the University of New Brunswick and the University of Maryland calibrated their model to the maritime region using 30 climate variables. So the calibration is particularly important to climate scientists who could then inform any sort of future decisions when it comes to management within our personal lives, or as a farmer when it comes to greater land management. We can run these models numerous times at different resolutions to give us a wide range of values and also to give us a broader picture as to what may be happening in the future. Now, ultimately, as I said, we can't rely necessarily as individuals, if you don't have the technical expertise, it's hard to look at the technical details in the model, but we can rely on the outputs that are being translated by these climate scientists to give us a better understanding of what climate change may look like for the maritime region in the future. Now, this model has predicted some outcomes already up to the year 2100. So as Linus said a little bit, they predicted to see wetter winters and springs and drier summers. So increasing precipitation, possibly worsening in flood events. So adaptation for structural resilience. I'm not an architect myself or a structural engineer, but this is something that has been done in other places, and we can certainly move towards it or look to move towards it in New Brunswick. So structural resilience is the design and construction of structures utilizing materials and engineering to reduce structural impacts from extreme natural events. Now, flooding is a particularly notable event in Fredericton annually and other parts of New Brunswick, of course. Some strategies to help mitigate and adapt to these extreme events include elevating our lowest floors above flood levels, flood-proofing homes and essential structures, utilizing materials like brick and steel, and also closing off foundations and building structures above the floodplains. In some regions in New Brunswick, they put similar strategies into code. So, for example, the local service districts of Magersville and Sheffield in Sunbury County, within the parishes, building code stipulates that any sort of new developments must have a minimum elevation of 7.3 meters. And this number was determined based off the highest flooding levels from 2018 flooding. And Tim is going to take it from here and look into regional planning.
Max. Thank you. So I'm going to take it to the regional planning. So I think this is a under talked about issue for the future of climate change, especially in New Brunswick. So regional planning is essentially planning for climate change. We know it's happening. We know it is going to continue to happen. So it's very important for us to plan, to be proactive instead of reactive. So there is a growing importance for communities to work together with other communities as well, and as regions to create these climate change mitigation and adaptation plans. So these are proactive measures and strategies to plan for the impacts of climate change. And it touches on public health, transportation, infrastructure, emergency services, local agriculture and industry, tourism, education. All facets of life are touched on by climate change. So you have to plan for each individual one, and it's not a blanket approach. And it's not a blanket approach that can be applied for all of New Brunswick either. You have to create ones for individual communities, and they have to be cohesive so that communities can work together as regions. So this is a form of community resilience. You know it's going to happen, but it's how you react which measures how resilient you are as a community. So as more information becomes available, it really should take on an adaptive management approach. These shouldn't be a static plan that you make and then 20 years later it's the same. You should be revisiting it and making sure that it is appropriate for new information that is coming out, appropriate for trends that are coming out, and it should be adapted. And there's no shame in adapting a plan. It's actually a strength because you realize at one point in time you don't know exactly what the future is going to look like, and there is uncertainty. So these plans have to be adapted as more information comes out. And again, coordination has to happen within communities and between communities so that a whole region can be prepared and plan for the changes that climate change will bring. And so as part of our work, excuse me, we have developed a couple literature reviews on regional planning, so current policy in effect and current climate change mitigation or adaptation plans in effect. So there's going to be a portion in the feedback form that talks about if you would like any additional resources or have any more comments on our webinar. So if you would like access to those literature reviews, we would be more than happy to share them with you. It talks about basically all of the communities, not only just in New Brunswick, but in other parts of Atlantic Canada as well. So it just shows what the current approach is and maybe any limitations going forward. So I'm going to, I believe, pass it back to Max. I'm going to pass it back to Max now.
Okay, perfect. So just some further adaptation strategies to go over. So climate-friendly agricultural practices. Now, there's a couple ways we can take this. We're going to look at it from just a little bit from both a home enthusiast side of things and also on a larger scale agricultural operation. When it comes to climate-friendly agricultural practices, obviously agriculture is very important in our food production system, but we can certainly again look to strategies that are more climate-friendly. So for home enthusiasts, we look at permaculture. So permaculture is adopting agricultural systems that are self-sufficient and sustainable, focusing on principles such as crop diversity, resilience, and natural productivity in the smaller agricultural system that homeowners are working within. For larger scale agricultural operations, strategies can include establishing and protecting riparian zones along waterways. I'm sure many farmers are well aware of the challenges that annual flooding presents to crop productivity within the Wolastoq region, and lack of riparian zones along waterways certainly contribute to some of those impacts associated with annual flooding. So establishing and protecting riparian zones along these waterways help with soil stability and help reduce erosion of the banks, which ultimately help contain the channel and prevent the banks from breaking as easily. Establishing crop rotation practices. So ultimately that comes down to rotating your crops into different fields, possibly to reduce any sort of degradation of the soil from annual agriculture in one specific spot. Planting rows of trees between crops to act as a natural windbreak and to prevent soil erosion, and then using biodigestive systems to produce fertilizer. So a biodigestive system is essentially a closed system that's airtight, that uses excretion, so animal waste, to produce biogas and fertilizer. And for larger scale farms, as Linus was talking about a little bit earlier, using decision support systems where data can be fed into a computer program and help determine agricultural decisions, especially when it comes to things like crop rotation, which is important, and that is being developed with the research that is being done. And then lastly, on my end, it's to protect and conserve natural spaces. So according to CPAWS, the Canadian Parks and Wilderness Society, about 5% of New Brunswick is protected. So that's about 272,000 hectares is currently protected. But we need to do more. We need to focus protection on wetlands and forested areas. The province has committed by 2023 through the Nature Legacy Initiative to protect 10% of land within the province, but only time will tell if that commitment is met. But we need to focus on these natural spaces, particularly wetlands and forests. Forests are natural carbon sequester, or they provide natural carbon sequestration, and wetlands also help with flood control, providing water retention, but also providing a plethora of different ecosystem services such as habitats for species at risk. So we need to push for increased comprehensive policy protection of these special natural areas at various levels of government, regionally, provincially, and ultimately federally as well. We need to minimize deforestation and degradation around important natural spaces. So the protection of natural spaces themselves is not enough. We need to reduce any of the effects from large-scale construction and development around these natural spaces, creating and stopping these developments from creating essentially an island in which you have natural spaces surrounded by high-level development. We need to reduce landscape patchiness by increasing protected areas. So when it comes to things like ecology that are concerned with metapopulation dynamics, we need to reduce landscape patchiness, which are isolating certain populations of organisms, and the effects that come along with that, such as breeding within small populations, increasing any sort of negative impacts that are associated with breeding within a small gene pool. And then lastly, buying local, wholesome products for consumption. So going and utilizing your local farmers markets, or going to your local farmers and buying products directly from them that haven't been altered using chemicals or fillers. So those are just some strategies of becoming a bit more climate friendly and ultimately adapting to climate change, as it's something that is going to affect us and it's something we can't avoid. And now I'm going to hand it off just as we wrap up for our presentation.
Thank you, Max. So in the previous two webinars that we've had, we send out feedback forms each time. And in the feedback form, there is a space to leave any questions, because I know it always happens to me. You have a question after the webinar. So the following questions, the next two slides are questions from outside of the webinars. If you have any questions now, you can put them in the chat and we will get to them. But the first question, I believe this may have come from our webinar back in December. Someone wrote that they are concerned about blue-green algae, summer water flows, and forest fire danger with drier, hotter summers. So this to me essentially speaks to the importance of regional planning, because these are very valid concerns with climate change, with drier, hotter summers as well. So, and these are effects that they are likely to happen, but they can be mitigated. So it's very important for communities to plan for things like these, because it is a very valid concern for people around New Brunswick as climate change continues. And I would invite the researchers on this project, Dr. Charles Bork and Dr. Jean-Yu Shi, if they want to take a stab at the next few questions. We did have an excellent submission from Daniel, who is in the call. On the next slide, it was talking about how these webinars are a great resource, and also he had many questions that could be answered during the webinar and could be essentially a basis for a future webinar as well. So he put a lot of questions there about causal relationships and indications and whatnot. It's a lot of information to just be seeing for the first time. So it might be better answered in a future webinar, but we will be sure to pass this off to the researchers as well, if they can't be answered today, that is. We also had another question in the chat come in from Daniel again. So I believe I gave mic and camera privileges to Dr. Bork and Dr. Shi, if they would like to try to answer these questions. As for planned future research on hydrology and forest management, I believe that this definitely would be in the plans. Even this research on the hydrology and land use change is still ongoing. Like, we are not in the end stages of it yet, it's still ongoing. So they are having new results all the time. But if anyone else has any questions here, feel free to put them into the chat.
So did you want me to address the second point a bit in terms of planned work?
Yeah, for sure.
Yeah, one of my research interests relates to looking at the ways that we use the land and how the land might impact things like hydrology or even more localized weather. So there is an initiative, I guess, it's been there for as long as I've been at UNB. That is essentially the area that I am particularly interested in looking at. So yes, there is, as long as I'm at UNB in my capacity as professor, yeah, I will be looking at the ways in which hydrology, meteorology are impacted, not necessarily at the landscape scale, certainly that's of interest, but also we might look at finer resolution relationships.
Thank you, Dr. Bork. I was also looking at question number 2. Is there an indication that climate change will impact stream flow with the risk of frequent major flooding soon in New Brunswick? And I was thinking, would that relate to the snow-dominated system in the winters transitioning into a rain-dominated system? Would we likely see major flooding in the winter? Or is it still predicted that it would be in spring due to snowmelt for the time being?
Well, yes, for the time being, let's look at it in terms of the near future. That is the expectation that there will be continued spring melt and and that relationship to river high water or peak flow. But in terms of the of climate change over the long term, things may look different because of the way that the watersheds will slowly transition from being currently snow dominated to being more rain dominated. And so with the rain dominated system, that applies throughout the whole year. If you look at the precipitation, typically it's available most of the year. There's certain periods of the year there's slightly greater amount, but generally for this area it's pretty well uniform in terms of precip, and that will be with the rain dominated system. That will mean that the precip will immediately lead to potential flooding. But the point is that with the rain dominated system, there's a greater distribution of rain throughout the year. With snow dominated, you have an accumulation of snow, and that occurs during the accumulation season. And in some parts of the upper basin, St. John River or the Wolastoq basin, you can get close to, or in one case, close to 2 meters of snow. So all of that snow, if you envision that melting pretty well within a week or two, there's significant amount of water associated with that. So the timing of peak flows may shift, and it may mean that the actual peaks will not be as high because of that distribution of precip over the whole year with a rain-dominated system.
Great. Thank you, Dr. Bork. I just want to address Daniel's most recent question in the chat. In a study of stream flow response to land cover change and climate change, how does Reg CM4 input into wet spot improve overall result output? Now, feel free to correct me if I'm wrong, Dr. Bork, Dr. G, but I don't believe it's the aim is to really improve the output. The model has been calibrated quite closely to the region, but the advantage of using RegCM4 is that we can predict future stream flow, future flow dynamics as the climate changes, because RegCM4 is so much more localized and such has a higher resolution than the global climate models that we're used to.
Yes.
Okay, perfect. That's so Daniel, I hope that answers your most recent question. Dr. Bork or Dr. G, would you like to take the question prior to that on the variability of impacts on stream flow with the two different concentration pathways of 4.5 and 8.5.
So which question are you referring to here?
Daniel's question in the chat, based on antecedent, present, and future climate data from the study area, what are predictions on climate variability impacts? Yeah, with RCP 4.5 and 8.5.
Yeah, well, with RCP 4.5, that is sort of an increase from what we currently have, but there's an assumed change in human behavior. At least this is the scenario that this particular RCP 4.5 addresses, that there'll be a change in using more technology by the year 2040. And with that, there will be there will be increases in temperature, but not at the same level as what you would expect with the more severe scenario as RCP 8.5. 8.5 is, you can view that particular scenario as business as usual, meaning that without any change, and given the current emission rates and the expected emission rates in the near future, that will lead to even higher amount of warming. And associated with that warming, there will be increases in precipitation as well, mainly as what Linus discussed earlier. The air is becoming warmer, therefore the amount of water vapor that can be taken up by the atmosphere increases. So you get much more transfer of water vapor from the southern parts of the continent, and that will lead to increases in precipitation events in some parts of southern Canada, maybe up in throughout all of New Brunswick. So yeah, the two scenarios are somewhat different, and both of those two scenarios are being modeled. And the other scenario that we paid particular attention to was actually a weaker scenario, which is RCP 2.6. So the RCP 2.6 is probably does diverge somewhat from current conditions, but the divergence is actually quite small compared to RCP 4.5 and or RCP 8.5. So the idea with these models, what they show, typically they provide a reference period. So that would be during the past, and that reference period is used as a standard that you use to compare the changes as you move into the future. And so typically if you look at the trajectory with respect to temperature, what you'll see with RCP 4.5, by the year 2100, the expectation is that the temperature on average for all of New Brunswick is increases about 1.4 degrees Celsius. Now, if we go with the RCP 8.5 being the worst case scenario, that increase by 2100 would be around something like 4 degrees. So you know, these different scenarios gives us, you know, a layout of how things may develop into the future. And so as indicated before by Linus and others, there's about 30 variables that are being estimated or modeled, and these variables go from temperature to you know, snow on the ground to snow melts. So a lot of different variables that are used because different ecosystems sometimes require different you know, variables, climate-based variables. For example, recently a colleague of mine asked about the availability of snow depth on the ground during the winter, and how might that change as we go into the future. He looked very hard around for that type of information, but that information wasn't available from any sources that we can envision, from ORNOs to other you know, outfits that give this type of information. It wasn't available, and also an important part of the simulations using Bridge CN4 is the resolution. I don't think there's very much information out there at a resolution of 5 kilometers. Most data or products I've used are somewhere around 50 to maybe 45 kilometer resolution. So the extra detail we provide allows to look at how topography has an impact on the local or regional climate. So topography is a very important you know, consideration when you're looking at how climate varies as you go from point A to point B within the province of New Brunswick. So the highlands, the response is very different than what you might expect to see in the lowlands of New Brunswick, for example.
Thank you, Dr. Bork. We do realize it is now past 1 p.m. If you have to go, since it's the end of your lunch break, I'm putting in the feedback form. If you could please fill this out, this will help our team and the future team, I'm assuming in the fall, put together even better webinars for you. It just asks some questions about your experience signing on, the quality of the call, and if you have any comments, and if you would like any of the resources, there is a portion in there you can fill out. But if you are free to stick around, we still have some time if you want to send any more questions in the chat. We would love to get to those as well. I'm also going to put it on the next slide just for a moment. We do have a Facebook page. If you search up at Wolastoq Climate, you can put it there. We'll also drop a link in the chat as well. Our website is also in the chat. If you scroll up, it's the title is Hydrological Research on the Wolastoq. And we can also send you reports, and you can shoot us an email as well. We've sent you numerous emails now about the webinar, so you can find it on there. But if you have any other questions, please put them in the chat and we'll get to those. I can talk on question 6 here about courses at UNB aimed at addressing any knowledge gap. And through my experience in the Master of Environmental Management program, a lot of the classes have spoke on the issue of climate change and how things have to adapt and how we have to adapt to climate change. So I've taken a Biophysical Foundations of Watershed Management course last fall, and we found ways to measure river health through benthic macroinvertebrates. And as the temperature increases, that could change what macroinvertebrates are good indicators for river health. So it's a subject that is spoken about in pretty much all of the classes. But I would say that there is room for, a forest flood and climate change class specifically in the forestry department or environmental management department as well. Linus, did you want to hop on?
Yeah, I just want to touch a little bit more on that. There are courses that use some of this research as well. Currently, Max and I are taking a forest, watershed, and fire management course with Dr. Bork, and we do touch on some of these subjects, things like how land use can change the way that flow occurs downstream, and we've done a couple of labs on that sort of thing. And then I know last webinar we had a very similar question, and I know Dr. Bork is working on making a class that is fairly specific to this research and this sort of area in how climate change and land use and those two work together, particularly with respect to hydrology. Let's see if there are any other questions here. Yeah, so for question 5, are these existing integrated models or are they new ones being developed to address the flood risk? So in terms of this research, Reg CM4, SWAT, and WetSPA, they are existing models, and then they were calibrated specifically for the upper Wolastoq Basin. Again, they can be modified on a case-by-case basis to fit different watersheds and different regions. Right now, Reg CM4 covers most of maritime Canada, whereas I believe SWAT and WetSPA are a little bit more specific to this watershed right now. The decision support system, I believe, is going to be relatively new, pretty unique, although it is going to be based off of SWAT and putting that into a GIS sort of context and using GIS interface. That's what I was looking for. So we have a little bit of old being mixed in with a little bit of new. So there's lots of adaptation, and hopefully the fact that these are adaptable to different regions should give those tools greater flexibility so that they can be applied upstream, downstream, and across Canada, specifically with respect to climate change. If there are any more questions, please put them in the chat now. I think we're going to keep the call open for about 2 more minutes. We'll cut off at 1:10 Atlantic time. So we have 2 more minutes for questions. Please put them in the chat. We'd love to answer them right now, especially when we have a couple of the researchers here while we're talking. If not, again, please do give our Facebook page a follow. We'll keep you updated on any future events. You can also, it would really, really help us if you put in your feedback into that feedback form. It really helps us figure out what we should cover next time, what we did well, what we can improve on, and really just any feedback is greatly appreciated. And we'd love to hear from you via email as well. Answering questions is part of the job. It's a lot of fun. All right, well, it seems like we have no more questions. So thank you everyone for joining. We are gonna go ahead and wrap up now. Again, thank you so much. We really appreciate it. Tim, Max, and I have had a great time through these 3 past webinars. If you would like a recording of the webinar, if you'd like the technical report, please find it on our website, follow us on Facebook, shoot us an email, fill out the feedback form, and let us know. And again, yeah, thank you so much. This has been a blast.
Thank you, everyone. We'll make sure that any of your questions in the feedback form get sent to the researchers and the next student team that takes over from us, as we are essentially moving on from UNB after this semester. But we've had a heck of a time in this course, in the last course, as this is an extension of our practicum. So We'd like to thank the research team, Charles Bork, Jean-Yu Keen, Amish Shelby, and Kim Reeder as well, just for their guidance and mentorship throughout these last, I believe, 6 months or so. But thank you, everyone, and have a nice day and a nice weekend.
Thank you very much.